In this interface, we have only 3 sets. So the easiest thing is to delete all the three sets by clicking remove all MS. The MS stands for membership function. So we can remove them first, and then we can go to this menu again by clicking edit, and then add MS as membership functions. And in this block, in the dialog box, we can specify that there are 8 fuzzy sets for the signal E. And also we can specify the membership function. For instance, we can still use the triangular membership function. And then we can click OK. So there should be 8 membership functions. And we should be noted that these membership functions are okay, but not this one and this one. For these 2 membership functions, we are expecting something like this. For negative but approaches to 0, and the other one should be something like this, positive but approaches to 0. So we have to modify the membership function using a mouse. So we can click this one and move signal to move the membership function, the curve shape. Like this. And we can do it to this membership function. We can edit them easily. And also we can change the distribution of the membership functions as we need it. The mouse is not that good. So we can modify them in this way. And also we can rename the name of the site. For instance, we can rename this one to negative big. We can rename this one to negative medium. So we can change the name of this set because we will use the names later. So we have to change all the names. Similarly, we can do the same thing for the 3 signals, E, ED, and U. We can do the similar thing for the 3 signals. We can modify them, and then we can establish the fuzzy inference system. Let's see how can we do it. If we double-click the fuzzy inference system, then we may get a dialog box like this. And in this dialog box, we can type in all the 64 rules. We say 64 rules because we have a fuzzy table like this. So there are 8 combinations of ED and 8 combinations of E. So there could be 64 rules. We have to input these rules one by one. Let's see how can we input the rules. For instance, if E is NB and ED is NB, then the variable U should be NB. So let's see how can we input this rule. Let's see, this is the E combinations, and this one is the ED combination. Of course, there are not enough elements in the ED because I didn't modify it. If you modify it, you will have equally number of combinations in each E signal. So what we need to do is to select the combination of E like this. When E is NB and ED is MS1, should be equivalent to the NB. Then U should be MS1, or you can use different combinations. So in this case, you can establish one of the rules. Once you have finished the rule, then you can click Add Rules. So you can click one rule here. And then you can go back to the fuzzy inference table to find another rule. For instance, E is still NB, and ED is the second element. This one. E is still NB, but ED is another element. Then we have to use this table to create another rule according to the rule table, and then we can add another rule. So in this case, we can enter all the 64 rules. And then, since we have finished expressing these two signals and the output signal and also the fuzzy inference table, we can now save the whole fuzzy inference system. We call this one the fuzzy inference system to a file. You can export it to a file, to a workspace. If we click this menu item, we can do things like this. We can specify a file name here, and the extension of the file is FIS for fuzzy inference system. So we can save this file. For this example, I have already saved one of the fuzzy files, C7 SAPD. So we can recall that file, fuzzy C7 SAPD. We can recall the fuzzy set, and we can check the membership function. And you may see that this membership function is very close to the one I created later. Like this. And there is a fuzzy inference system with all 64 rules I've created. So here I have created a fuzzy inference system already. Now let's see how can we simulate a fuzzy inference system. Actually, I have already drawn the Simulink model. C7N fuzzy PD. So this is the fuzzy inference system. And the fuzzy inference system should be exactly the same as the one I described earlier in the slide. In the system, we noted that here this is the Planck model, and this is the fuzzy controller model. It includes the fuzzification, fuzzy inference, and the defuzzification in this part. So we have P signal here and D signal here, and also this is the control signal. And with the use of this kind of system, we can easily simulate the fuzzy PD controller. And finally, we should get the result like this. And this process could be very slow. So I mean, not run the whole